Hello friends, I welcome you in lecture number 38 on Laplace transform. In this lecture we are going to talk about convolution. So first we understand the definition of convolution. Convolution is the operation between two functions. For example, we are familiar with the operation of addition for two functions. Suppose I want to add two functions f and g, then it is defined as f plus g of t equal to f of t plus g of t. So here addition is an operation between two functions f and g. Convolution is also one operation between two functions. Suppose I have two functions f and g, then operation of convolution between f and g or convolution of f and g is denoted by f star g, and if f and g are functions of t, convolution is also a function of t and is defined by integral from 0 to t f of u g of t minus u du. Here u is dummy variable and limits of u are from u equal to 0 to t. So if we integrate this f of u g of t minus u with respect to u from u equal to 0 to t, then we will obtain function of t, and that function is called convolution of two functions f and g. This is the definition of convolution, which is operation between two functions. So sometimes they can ask you the definition of convolution, and you can write in this way: the convolution of two functions f of t and g of t is denoted by f star g of t and is defined as f star g of t equal to 0 to t f of u g of t minus u du. We understand this definition with this example. Here we are asked to find out convolution of two functions t and e raised to t. So we consider one function as f of t and another function as g of t. Let f of t equal to t and g of t equal to e raised to t. Now definition is f star g of t, that is convolution of f and g, is equal to integral from 0 to t f of u g of t minus u integration with respect to u. So because f of t is t, f of u will be equal to u, and we require g of t minus u. So g of t is e raised to t, therefore g of t minus u is e raised to t minus u. Now we apply the definition. By definition, convolution of f and g, which is also a function of t, equal to 0 to t f of u g of t minus u integral with respect to u. F of u is u and g of t minus u is e raised to t minus u. So we substitute these two, u times e raised to t minus u du. Here integral is with respect to u, so we will consider t as constant, and this I can rewrite as e raised to t times e raised to minus u du. And because integral is with respect to u, this e raised to t can be taken outside integral. It is independent of u, therefore we can take it outside integral, and we have to integrate u times e raised to minus u with respect to u, and this we can do by using integration by parts. So we consider u as it is, integral of e raised to minus u, which is minus e raised to minus u, minus derivative of u is 1, integral of minus e raised to minus u is e raised to minus u. Integral has limits 0 to t, So we have to put u equal to 0 to t. This is using integration by parts. Now we first simplify this bracket. It is minus, we can take minus e raised to minus u common, and here we are left with u, and here we are left with plus 1, u equal to 0 to t. Now we substitute values of u. First we put u equal to t, and we have minus e raised to minus t, t plus 1, minus of lower limit, and there is one negative sign here, so minus minus plus, u equal to 0, therefore this is going to be 0 plus 1, that is 1, and e raised to 0 is 1. And finally we can simplify this. We multiply this bracket by e raised to t, so we have e raised to t into e raised to minus t, which is e raised to t minus t 0, and plus e raised to t, and e raised to 0 is 1, and we can take this negative sign inside the bracket, and we have obtained the convolution of functions t and e raised to t. Therefore f star g of t equal to e raised to t minus 1, and f of g was t, f of g of t was e raised to t. So this is our answer, e raised to t minus 1. So in this way we can decide the convolution of two functions, and we are just using the definition of convolution. We have to integrate f of u times g of t minus u with respect to u from u equal to 0 to t. So in this example we have obtained convolution of t and e raised to t, which is e raised to t minus 1. Now convolution operation is commutative. For example, we know that if we consider addition of two functions, then we know that f plus g and g plus f are always equal. That is, commutative property is satisfied for addition operation. So as in the case of addition, convolution operation is also commutative. That means f star g and g star f are always equal. That we can prove by definition also. So here we have written this remark that f star g of t equal to g star f of t for any two functions f of t and g of t. That is, convolution satisfies commutative property. So we start by f star g of t, and we will show that it is equal to g star f of t. By definition, f star g of t equal to 0 to t f of u g of t minus u du, and we want to prove that this is equal to g star f of t. So that is equal to 0 to t g of u f of t minus u du, and instead of u we can use the dummy variable also. Suppose I want to write down g star f of t. By the definition, it is 0 to t g of u f of t minus u du. Now instead of u I can use some another variable also. So here I replace u by some another variable, say v. So I want to prove that this f star g of t, that is this integral 0 to t f of u g of t minus u du, is equal to this integral. So from this we can have the idea that if we compare these two, g of v f of t minus v, and here we have f of u g of t minus u. So if we compare these two, then we may have the idea that we have to change our variable u from u to some another variable, and here we require g of v. So this suggests us to consider the substitution for t minus u. We will assume t minus u equal to v, and then we will simplify. So let t minus u equal to v, and if we differentiate this both sides with respect to v, then we consider t as constant and derivative of u with respect to v equal to derivative of v is 1. Therefore minus du equal to dv, and therefore du equal to minus dv. Now we are changing our variable from u to v, so everything which is in terms of u must be converted in terms of v. So we will replace this t minus u by v, and we will replace du by minus dv, and we will replace u by t plus v. From this not t plus v, if we consider u on right hand side, we have u equal to t minus v. So this u will be replaced by t minus v, t minus u is replaced by v, and du is replaced by minus dv. And here limits of u are from 0 to t, so we have to decide limits of v corresponding to limits of u. So if we take u equal to 0 here, then v will be equal to t, and if we take u equal to t, v will be 0. So that I have written here. First we consider u minus t minus u equal to v, then minus du is dv, therefore du equal to minus dv. Now from this we can find out limits for v. If we take u equal to 0, we will have v equal to t, and if we take u equal to t, v will be 0. Therefore this is converted into limits are from for u equal to 0 we have v equal to t, for u equal to t v is 0. Now value of u from this is t minus v, so f of t minus v, t minus u is considered as v and du is minus dv. So that step I have written here. Therefore f star g of t equal to integral from t to 0 f of t minus v g of v minus dv, and because of this negative sign we can write these limits as limits from 0 to t g of v f of t minus v dv. Here we are using the fact that integral from a to b equal to negative of integral from b to a. So here we have negative of integral from t to 0, that is equal to integral from 0 to t, and if you observe, this is nothing but g star f of t. Therefore we have shown that f star g of t equal to g star f of t. So convolution is commutative. So when this property is helpful, so this property is helpful in deciding that we know that f star g and g star f are equal, and in the definition of convolution we consider f of u g of t minus u du, and this we can rewrite as 0 to t g of u f of t minus u du. So suppose I have convolution of two functions f and g, then I will consider that function as f, for which I can easily find out this f of u, and I will consider that function as g, for which I am comfortable with t minus u. For example, suppose I have sin t and 1, convolution of 1 and sin t, then I will consider g equal to this function, constant function 1, and I will consider f equal to sin t. If I consider g of t equal to 1, then g of t minus u is also 1. So that will be helpful in this way. Commutative property will be helpful in this way. Suppose we want to find out 1 star sin t, then we know that 1 star sin t and sin t star 1 are equal. Therefore we consider f of t equal to sin t and g of t equal to 1, and f of u will be equal to sin u from this, and g of t is 1 for all values of t, therefore g of t minus u is 1. Now we use the definition f star g of t is 0 to t f of u g of t minus u du. F of u is sin u, g of t minus u is 1, and we integrate sin u. Integral is minus cos u. Limits of u are from u equal to 0 to t. First we put u equal to t, and we will have minus cos t, minus minus plus cos 0 is 1, and convolution is 1 minus cos t. Therefore 1 star sin t is 1 minus cos t. So in this way we can obtain convolution of two functions of t. We have to just remember this definition. Notation is f star g of t for the convolution of f and g. Integral of f of u g of t minus u, integral with respect to u from u equal to 0 to t. So remember this definition. In the next lecture we will see how to obtain Laplace transform of the convolution of two functions without obtaining convolution using this integral. Without obtaining value of this integral, we are able to obtain Laplace transform of convolution. So that we will discuss in upcoming lectures. Thank you.